attendees are in listen-only mode.
Good morning, everyone. Good morning, fellow Golden Gate chapter members. We have a special presentation on PON testing and troubleshooting. Our presenter today will be Donavan, aka Tony Holmes. Tony Holmes, or Donavan, has a lot of experience in our business. He was almost 2 decades in field operations, working both as a field technician, network technician, head-end technician. Then he went into like construction design and leadership, and then started his own company doing construction design. He also is a application engineer, or currently applications engineer for VeEX. As you guys saw in the video, I'll start my intro before we turn it over to Donavan. I'll talk a little bit about some of the benefits to SCT. As you guys saw, we have a plethora of training. It's great to join the Golden Gate chapter and try to get out there and network with other SCT members, and we have the ability to ask questions to some of the industry experts and have them reply through our question and answer portal. So with that, I'm going to turn it over to Donavan, aka Tony, and let him go to work here and tell us all about PON. So thank you, Tony.
All right, no problem. Appreciate it, Woody. And I just want to verify that you're able to see my screen.
Yes. And one more thing, if you guys just, for the audience, if you guys put just your questions in the questions box, I will periodically read those out, and we will have a few polling questions that you can take your best shot at answering. We'll be going, we have 3 polling questions that I will present today. And yes, I can see everything fine. Thank you, Donavan.
Excellent, excellent. Now, thanks, Woody. And again, my name is Tony Donavan. Some call me T. Donavan, some call me Tony. However, this particular training, I'm kind of excited to give this one because talking about the PON technology, it's that new hot topic, that and the high splits, and I like to dive into those to make sure that everybody is very comfortable with that particular technology and how to troubleshoot it, what it is, kind of that foundation of it. So that's going to be the goal for this presentation, to cover everything from the going into a little bit of the high level theory. I'm going to go into what PON is and all that, but then I want to go into some true application as far as how it applies to a customer, but then also how do you troubleshoot it, how is it constructed and all of that. So So as an agenda, let's see, let me make sure I have my screen set the way that I want it. So here's an overview. So first of all, I just want to go into just comparing those fiber to the X technologies. You'll see it fall under different names, you know, fiber to the home, to the curve, so on. I just want to explain what that is and what it means to you. But then, now here's where it's going to start getting exciting is I want to go into what testing should be done and when. What testing should be done and when. And I'm going to look at it from some different angles. One is I'm going to go from a construction standpoint, and then I'll go into just that initial activation of the fiber itself. But now we also have to maintain it. So I'll go into the maintenance side of it as far as how to maintain a fiber to the X, FTTX. And then there's that customer installation piece. And there's things that and tools that you're going to need to have in order to one, properly install it, but even more so is to confirm that the customer is getting the services that they're paying for. So that's going to lead me right into using those fiber tools. Being able to use the fiber tools, and then I'm going to wrap it all up with for use cases for testing that layer one, which is at first the first layer, which we're talking about the actual fiber or the infrastructure itself, and then the layer four, which is our speed testing. You know, verifying that the customers are getting the proper speeds. So let's just talk about just comparing understanding when I talk about the fiber, the FTTX, or sometimes you'll hear fiber deep. You'll hear phrases like RFi or remote PHY and PON, which is what we're going to dive off into. All of that, if you look at this diagram here, and hopefully you can see. Okay, I'm going to have to use multiple screens here. If you can see my my mouse here, is that this is the head end view. So this is our head end view, and when you're looking at your fiber that's going across here from an RF perspective, you have what I call the legacy or the analog optics, which is your standard video overlays at 1550 that has your video content and come directly from the head end out to the field and then to the nodes. Now, when it's going to the nodes, now, you know, we've had the nodes for quite some time, but now here's the thing that systems are doing now is wanting to take that fiber deeper into the network. What that does is that look at it like this: when let's say we dropped a fiber node, and now it's running through a series of amplifiers. We'll just say it's running through 10 amplifiers. Every time you amplify RF signal, it also amplifies the noise floor as well. And the more times that you amplify it, the more that the noise floor tends to creep up. So it impacts the quality, and then also the saturation as far as the number of customers that are on that particular node. So what fiber deep does is that it says, okay, let's do something a little bit different. Let's now take this 10 amp cascade, we're going to drop a fiber further down. So now we're not running 10 amps. Now we dropped it down to 5 amps, or maybe dropped it down to 1, or taking it all the way fiber and no actives. So that's what we're talking about when we're looking at this scenario here. But now, inside of the head ends, back in the day when I've worked in head ends, you had racks and racks and racks on top of racks, a lot of equipment. a lot of that has collapsed down in the head ends, all due to CCAP. CCAP, what that allows is to now take that RF piece, and I'm oversimplifying this just for the sake of just kind of laying a foundation, is now taking that RF piece and saying, you know what, I can do this using my my IP addresses using Ethernet, similar to what you would do for streaming videos and things like that. You know, so it's able to now do it over the Ethernet, and that's what we're looking at this lower portion that is right here. So, and then via the Ethernet, now you're still going through the same type of a fiber optics, and going to your MUX, to where now you have your different fibers that are going out DWDM. So you're having different wavelengths for the transmission, then going all the way out into the field, whether it's remote PHY, which the remote PHY technically takes that head end piece, because remember the head end is where your CMTS is, where all of your cable modems talk back to. It's like an RF router in a sense. So it now takes portions of that and says, you know what, instead of having that in the head end, let's take it out a little bit further into the network, and that's where this remote PHY comes in. And then the same thing with the PON node. It's now taking this fiber, and now it's taking fiber all the way out to the premises. And now you're going to have something. And this is where we're going to talk a lot about, is the PON portion of it, is to be able to take that fiber all the way out to the premises, and then you have something similar to a cable modem. Similar to the cable modem, but I like to look at it as a fiber cable modem, just for the sake of this conversation. But it's able to take the light to the end, and now you have a cable modem type of device that's on that end of it. I'll explain in a little more detail going forward. So let's just talk about the technology a little bit. Now, remember I was saying that the FTTX, it has so many different flavors. There's that, some call it the FTTU, the fiber to the user. There's a fiber to the curb. It's fiber to the antennas, depending on where it's fiber. But ultimately, what this is doing is taking that fiber deeper out into the network, and in this case, taking it all the way to the termination spot, which is whether it's the business or it's the home, it's taking it all the way to that particular point. So now, how is all of that done? So from a PON perspective, there's what's called EPON and GPON. I'm going to discuss that first. So your EPON and GPON, if you notice that the downstream wavelengths is 1490 for both EPON and GPON, and it's 1310 for the upstream. This allows you to be able to get gigabit up or gigabit speeds for both upstream and downstream. So you'll hear these terms thrown around, EPON or GPON, and sometimes it gets a little confusing, like what is EPON and what is GPON? The difference between those is the standards body that actually governs that particular technology. So you have IEEE, which is EPON, which that is a more of a US standard, and then you have the ITU standard, which is an international standard. But when we're looking at it, the key difference between those, they both, as you can see, both get you that gig speeds for up and down. You see GPON even can go up to 2.5 gig on the downstream. So it shows the big difference is that for EPON, it has one single layer that carries the IP information, which is the data, your voice, and the video, all on a single layer. GPON, it actually provides 3 layer 2. So it breaks out those layers. There's a layer for the for your data. There's a layer for the voice, and there's a layer for the video. It's broken out. When I'm looking at a GPON technology, is that when it's GPON, it allows you to be able. There's the way that the content is broken out. When I'm looking at it with a PON analyzer, it allows me to look at more information, more what we call PONs, or looking at the data that's coming through and being able to analyze it, with it being broke out into the 3 individual layers, versus your EPON. Your EPON is all encapsulated on the one, so it's more of being able to view your power readings as well as your IDs. So now that's your 1 gig portion, but now there's 10 gig as well. So you have 10 GPON, and you also have XGS PON. Now, what I've seen a lot of here in the States is a lot of XGS PON. Now, for the EPON and GPON, I kind of see a split between different areas if they're using the EPON or the GPON. But I'm saying it's a little more standard for the XGS PON, which is the 10 gig down and the 10 gig up. It uses the downstream wavelength of 1577 and 1270 for the upstream. So in order to make all of this work, we have to have a point that all of our content is being originated from, which in this case is our head end, or what we call the OLT. That is the optical line terminal. Okay, so that's at the point of where the throughput, or your Ethernet traffic, is now being sent out to the field. An actual OLT, and like I said, it can be in the head end. There's times that you can have your OLT that's actually out in a cabinet in the field as well, and they can handle quite a few subscribers. Wait just 1 minute. Sorry about that. Yeah, so it can handle over 16,000 subscribers. Okay, and that's looking at 64 users per individual shelf. Okay, so this is where your Ethernet traffic is being generated from. Now, on the far end side is where you have your ONT or the ONU. Okay, now look at your ONT as what you would do in an RF technology as the cable modem. So look at the OLT almost like your CMTS. Look at your ONT or your ONU. Those are some interchangeable words as your cable modem or the CPE device, which would be inside of the home. Okay, and that particular ONU, when that is set in there, now you're going to have a way to be able to test it, and that's what I'm going to talk about a little bit further coming up in some later slides.
Before you move on to your next slide, T. Donovan, can I throw out the poll question based on the previous slide, but don't switch to the previous slide. So let's get this, because the answer's there. So I'm going to put this one up, and audience, take a few minutes to answer this. If you read the previous slide, it should be easy enough. If not, it might be a little bit challenging, but take your best stab at it. I hope everybody can see my screen. Oh, it says collecting responses. Okay, I'm getting answers.
All right. That's a good sign.
We got about 30% of the folks have voted, so we'll give it just another minute here. Well, the voting has slowed down. We got about 40% so far. So I think the best answer to this question is EPON throughput is limited to about 1.25 gigahertz. If you want greater throughput than that, you'll need to jump up to the 10 GPON, which is a little bit over 10 gigabits per second. Okay, I will close the poll and then we'll move along to Donavan.
All right.
Go.
Excellent. Okay, we should be back going again. And I was talking about the ONTs and the ONU, and like I said, my equivalence that I put to that is similar to the cable modem. Now I have just so you'll know, you'll see me looking up to the right hand side. I'm looking at a screen, and I want to be able to utilize my cursor. So that's the reason that I'm looking up. I'm not ignoring you. I'm still looking at you. But when you're looking at the actual setup, or the way that a PON network is set up, so our central office, our head end, or a distribution area, you have your OLT. Then you're going out via fiber to your patch panels. Then it's going out into the field, and then you're getting your going to your splits. Now, from that split there, that's what's now taking individual fibers from the splitter, and now it's taking it out. It's taking it out further. So you now have a drop going from this point here, and it's now going to the actual home or the business. It's a direct line, and that would be like the cable modem. So look at this fiber connected over to the split. Look at that as like a one very long coax cable, but it is fiber. It is fiber that is running to that particular point. Now, one of the things that I'll talk about later is that when you're installing one of the businesses here, that it's good to be able to verify, okay, is my fiber in good shape from where I'm at back to the splitter area? Because it's possible that there could have been some digging going on or what have you. So you would want to be able to use an OTDR to be able to shoot back towards the splitter, which creates a challenge when you are using an OTDR, which is an optical time domain reflectometer, which is a device that gives you a distance to the fault. And when I say a fault, I should say an event, distance to the event, because it could be a fusion splice, it could be a connector. It'd be able to show you those particular things. But when there is light, and in this scenario, if I'm trying to look at the footage or look at the fiber from this end point, and if I am tied into the splitter, I'm going to have light. Whenever there is light on a fiber, you do not want to have that going into an OTDR, because it will blind the OTDR. You will not be able to make a measurement unless you have a filter on it. So what the filter does is it says, okay, I know that I have these wavelengths that's coming into me, or I have this light that's coming into me, but I want to block all that out. and leave me just a tunnel that's going to allow me to be able to still utilize my OTDR. Typically, that's going to be 1625 or 1650 nanometers, and you're going to be able to now have that little tunnel through, and you'll be able to look at your our OTDR, the fiber, even when there is light on it. But it's important to understand that you have to have a filtered OTDR in order to make that measurement. Okay, so just keep that in mind.
A question, T. Donovan.
Yes.
So the filter is usually built into the instrument, or is that an external device?
Yeah, a very good question. So with the a lot of test sets today, or quite a few test sets, I should say, has an auxiliary port on it that has the filter built in. So that's something on VeEX test sets. We have filters that are built in it if it is ordered in that fashion. But let's say that you have an OTDR that you never imagined that you were going to have that there was going to be light that you're going to have to shoot through. You can also buy external filters that can go on the OTDR as well, that still does the same thing, that it blocks out all of the light and only leaves that tunnel for 1625 and 1650 to still pass through.
I have another question in the questions box. So is there a distance limitation to PON technologies?
Well, it's really, I wouldn't say there's a necessarily a distance limitation other than based off of the amount of light that's coming through. So, and there's different factors that's going to impact that. I mean, it can be your split. You know, if you're a 16 by split, you're going to lose more light than you are if it's an 8 by. So yes, it has a similar limitation. I don't have the exact number as far as footage is concerned, but just remember the factor that is going to impact how far you're able to take that is depending on how much light that you're starting with. And that is that's impacted by the number of times that the light is split.
And if I could, I'll weigh in on this a little bit. So if you're using an FLM technology, then your input, minimum input level to your FLM determines your light level. So yeah, so not only is it that limited by distance, but it's also limited about what other kind of devices you have in that on that fiber line. So if you have other couplers and muxes and stuff, then you may not have enough level. So kind of all depends on the design.
Yes. Thanks, Woody. Very good point. All right. So we'll keep it rolling, and we definitely encourage the questions. So as I'm going through this, if there's more questions that come up, continue to chat those and put those in the question box, and we're going to address all of them as we go. But then at the end, I did mention this at the beginning. At the very end, I'm going to do what I like to call a roundtable discussion, to where I'll just kind of make sure there's no more lingering questions, and but then it'll give you that opportunity in case there's something that you may have thought of after hearing another question that you want to ask. I'll leave that time as well. Okay, so looking at, let me make sure. Okay, so I was talking about the OLT. And so remember, so if this is our let me point to the right screen. If this is our OLT, remember this is where I consider that to be the head end, or equivalent to like your CMTS in a sense. So the way that your OLT sends traffic, because it's using, because remember I said downstream for a 1 gig is uses 1490. Okay, so but if it's all using 1490, one would ask, man, doesn't your traffic collide there? Because there's multiple ONTs that is being communicated with. But no, it doesn't collide because it uses what's called a TDM. That stands for time division multiplexing. And what that does is that that's a method just of transmitting and receiving independent signals over a single path. And the way that it happens is all with the synchronization between the ONT and the ONT and the OLT. There's a lot of acronyms here. So the ONT and the OLT. So what the OLT does is that when it's talking to all of the ONTs at the end, it's now going to synchronize with those and say, hey, I'm sending your traffic now, and now I'm getting ready to send it to traffic to number 2 that goes to 2, and it just goes in that communications. That's that handshake or that synchronization between the OLT and the ONT. That's the reason that they do not collide. So now going on the upstream side, same type of thing. Is that when you're looking at your OLT, so I'm sorry, your ONTs, so it's doing a similar thing. Still with synchronization, it says, okay, I need to send my information, but I don't want to send mine the same time as ONT number 2 here. So what it does is that this handshake says, okay, it's your turn now. Now it's your turn. Oh, now it's your turn. And now it allows all of the traffic to be sent without it colliding. Okay. Now, one of the things that can happen, or what you can see on a when you're looking at a particular fiber, is that it's possible that it could have a downstream video overlay. That's at 1550, or what I like to call the analog fiber, or sometimes you consider it kind of the legacy fiber. That's what has your content for your video content. That can be overlaid right with your 1490 as well, which I'm going to talk about how that can actually confuse your power readings when you're getting ready to make the measurement. I'll talk about that shortly. So now like I mentioned, is that when you talk about the transmission, the way that all of this is able to be successful, it's all based off of handshaking, which is the TDM. So let's just talk about where and what to test. So similar to the drawing that I was showing before. So now we're looking at this area here, which is where we have where everything's being generated from. This is where we have our OLT that's positioned here, and then you have your different different wavelengths via DWDM that is now coming out of that particular source. It is going out into the field, hitting your PON splitters, and then that's where it's breaking out. Now, depending on where you're at, there's going to be different tools that you might need. Now, this little guy here, that is your fiber scope. So I always like to put in this plug for the fiber whenever you take a connection off of the fiber and you put it back together. You always want to clean that connector. Clean the connectors. You cannot clean it enough because just breaking that connection there, and it's possible that dust can get on the connector. When you marry that back together again, that dust now transfers over to that particular socket. Now that can impact your light levels and so on. So not just the connector itself needs to be cleaned, but the bulkhead itself. Clean both sides. But then you also have, since I talked about that this is DWDM or multiple wavelengths, you have to have something that's going to be able to see those multiple wavelengths. that's where we start talking about an OSA, which is an optical spectrum analyzer, or channel checkers, making sure that it's the right channels going to the right ports. That's how you identify it, okay? And then you could also have some monitoring type things in the head end to make sure that your fibers aren't dropping out or anything. You want something that can give you an alert if there's any issues that's going on. But then once you're outside of the head end, now this is when I'm wanting to make sure that my fiber from a construction end of it, that everything is looking good. So hey, having an OTDR is going to be that perfect solution for something like that. And then having your PON analyzers down at the end, or PON meters, or power meters, depending on what you're measuring, that's now going to happen at the CPE itself or at the premises. So from an activation stage, so let's go ahead and switch gears to that. So when you're looking at your PON activation, remember we've talked a lot about this, to where you have your OLT, which is usually in the CO, or that central office. And then you have your splitter cabinet, which is where all of your all the drops are coming to. It's that one central point. And unlike with your when you're doing the RF, you know how a lot of times you have a tap spaced every other home. The thing about fiber, because it can run a longer distance, is that you can have one split that is, you know, a ways away from where you're at, which is one of the reasons that a OTDR with a filter on it can give you the distance, so you know what type of loss that you should expect. But it's going all the way back to the cabinet. It can be in a area, and that one cabinet can be feeding 8 homes. It can be feeding 16 homes. If it's MDU, definitely feeding more off of one splitter point. And then the fiber is now going to its destination, which is at the premises itself. So for turn up, what I'm going to want to do is that first of all, depending on if you have a video overlay, that's at 1550. At 1550 there, so that RF video overlay. And then if you have a GPON, which is GPON or EPON, which is the 1 gig up to the 1.25, was one of your questions. So it's coming from the central office, hitting the splitter. Now I have to have a device that is going to be able to see what my light levels are. Okay, because remember we're talking about the activation. So I need to measure what my light levels are that's coming right to this point. And I'm gonna back up a little bit. Is that I want to make sure from a construction phase, when I am now putting this all together, I want to make sure that right out of the splitter that I'm getting the proper light levels based off of what the design says that it is supposed to be. So that's construction phase. Now, the other thing that I want to do is that with my PON meter or my PON analyzer, I want to look at the PON ID to make sure that, okay, is the fiber going to the right splitter port? Because remember, all of these individual fibers now, they're going to different homes spread out, and you don't want to plug your fiber into port number 3 when it's supposed to be in port number 4, because now you're going to be getting you're not going to be getting the proper information. Okay, so yeah, so you're checking your light levels at this particular point. Once that's all good and ready to go, then you can take it all the way to the home itself. Now, if you already have your ONT or that ONU inside of the home, then using a pass-through mode will allow you to be able to see the downstream and the upstream that's coming back to you. So now, remember I was saying that that you could have a RF video or that 1550 overlaid with the GPON. You could also have the XGS PON that's right on here, and that's that 10 gig PON. It can all go right on top of or utilizing the same fiber. The way that it's able to do that is it goes through what's called a coexistence element. Okay, that's what allows those multiple wavelengths to reside on that same fiber. But now it will add some complexity, and I'm going to talk about that coming up. But like I said, you have your at the premises itself where the CPE is. That's where you're going to be checking your light levels, making sure that everything is correct. So let's talk about using the actual fiber tools itself. Okay, so let's go back over to this point here. So we're looking at our head end. We're looking at the head end that's right here. This is where you're actually going to where the light is going out, whether it's the 1550 for the video, for your video over your fiber, or if it's looking at your PON, that 1490. But anyway, it's fiber coming directly out. And then it goes into the area, and this is now where the outside plant is. So now in a construction phase, is that this is where I want to make sure that the fiber between here that's going out to the field, that everything is good, and that's where the OTDRs come into play. But then you also have, since this is if this is all DWDM right here, now it's going to be important that we verify that the channels that we're supposed to see there, that they are actually there. That's where your optical channel checker or your OSA comes into play. Once it leaves out of this point, if it has the video overlay, then now it's going out to the node, and now you have all of your RF testing in that point, to that point. Now, if it's the PON, now you're looking at that 1490 for the 1 gig that's coming down. And I'm gonna hold off on something because I'm just itching to talk about the PON or using your power meters, but I don't want to jump ahead of myself. So, testing the PON networks. So, the basic testing scenarios that you're going to have based off of what role that you're playing at that particular time. One is having an OLTS. That's a construction phase. That is your optical loss test set. I'm going to show that. Then there's the broadband optical power meter. I'm going to talk about that. And now we have our PON pass-through meter, a filtered OTDR. Remember, I was talking about that a little bit earlier for in-service testing, and then having your PON analyzers to be able to look at not just your light levels, but to also look at the information that is associated with your light levels. And I'll talk about that. So let's talk about this first. In the construction phase, One of the things that that you're going to want to know is that based off of design, if it's saying that you should be losing from your OLT or from your patch panel out to the ONT is a certain amount, or out to your splitters, you need to have a way to be able to verify that that your losses are correct. One of your ways of doing that is using an optical light test set, an OLTS. So what essentially happens is that you're sending light out on one end, and then you have a power meter on the other end of it. So the first thing that I would want to do is that when I am at my when I am generating my light, I have my broadband power meter. I could go directly to the end, but I like to zero out my my light level so that when I go to the end, if I see now I'm at a -3, then I know that I lost 3 dB between that particular point. Okay, so that's what's going to verify that in a construction point that that all of your connectors, everything is good. You're not losing more signal than what the design said that it's supposed to be, or what's set up as the loss budget. You want to make sure that it's within what the range is when the based off of what the system design is. In this scenario here, since it's in construction phase, using a broadband power meter, no problem with your light source. So now the next phase is now doing just your power measurements. And this part of it, from a construction standpoint, hey, that's actually still pretty good. But now what happens if you have, remember I was saying that that you can have multiple wavelengths load or on top of each other, or both when you're using the power meter, that the power meter is seeing both of those particular wavelengths. One of the things that that can very easily happen, and I've seen this in the field, is that you'll take a broadband power meter, you're checking the light levels, you have it tuned to 1490 just like you were told to do. You got it tuned to 1490, but for some reason your levels are hotter than what it says that it should be. So you start scratching your head like, you know, why is this? Why are my light levels higher? But now, even though you're tuned to 1490 in this particular scenario, even though you're tuned to 1490, if 1550 is residing on that same fiber, it's going to look at the power of both of those wavelengths, even though you're tuned to the one. But the thing that's different is that with a broadband power meter, it does not just narrowly tune to the individual wavelength. And what I mean by that, it doesn't block everything out. It doesn't create a filter to where it only looks at that discrete wavelength. It's tuning to the wavelength, but it's whatever power is present, it is still going to impact your readings. So the big takeaway from this here is if you are on a system that has a overlay of your video, then you want to make sure that you're using a PON meter, not just a broadband power meter. If you do not have an overlay, if that's all that you have there is a 14, just that 1490, then hey, you're fine. You can go ahead and make that measurement without a problem. Okay. So now it's activation time. So now I have my ONT inside of the customer's home, and I want to make sure that everything is running the way that it should. So what I'm going to do is that I'm going to put an actual PON meter. Okay, so not just a power meter, but a PON optical power meter. So, because remember, the PON optical power meter, it's going to be able to look at the discrete wavelengths and not get impacted by the other energy that's coming through. So from a service activation phase, this is what I want to do. Now, if I have my unit equipped with pass-through, then I can take my light coming from the OLT, go into my test set, and then out of the test set over to the ONT. Now the ONT is back online, and I'm able to check my light levels coming downstream, the 1490, this is for the 1 gig, the 1490, and I can also look at my upstream, the 1310. I can see both of them together. And that's, that's a good test to run, because just because you're getting the proper light levels coming to you does not necessarily mean that your ONT is doing what it's supposed to do. Okay, so you want to be able to verify both directions. Okay. So this is an in-service type of split. So that ONT is going to be it's online, and you're able to then make your measurements going, or your power measurements going both directions. Then there's the OTDR. Remember, I talked about that. If I'm in a PON environment, then when I am wanting to see what if my fiber is good from where I'm at the end all the way to the splitter and beyond, then that's where I need to have a filtered OTDR, because I gave you that scenario earlier. Is that if I don't have a filter on it, my OTDR gets blinded, and I'm not able to get the measurements that I'm looking for. Okay. So part of the construction phase is that this is what I'm going to do to verify that all of my splices, my connectors, that I'm not losing more signal than what I should. I can also see what my total loss is from point A to point B. It'll give me all that information as well. And OTDR, when you're looking at a splitter, the OTDR will read through the splitter, but don't get that confused with a MUX. A MUX has individual assigned channels that you have to be tuned to that particular channel or that particular wavelength in order for you to go through that splitter. Okay, in order to do that, you would need a DWDM OTDR so that you can select the individual channels to shoot through. Okay. When you're looking at your OTDR, I like to use a link map view, and this is a link map view here. So you have different views that you can see on OTDR. One shows as a standard trace that shows where your splices, where I'm losing my my signal because of splices or splits. Or I can have it set up to where I can look at it in a pictorial diagram that outlines what I'm looking at, whether it's splitters or splices or at the beginning of my run. I can look at it all right here, and it gives me all the answers. So that's a quick way of being able to identify that everything is one, that I've identified everything that's there, but then also making sure there's not any excessive loss going through any of those particular components. And then the next portion is when I'm so let's say if now I've done everything. I went through and construction, we verified that, and the customer, let's say the customer was up and going. Now all of a sudden they're having problems. So now it's the perfect time for using an actual PON analyzer. Because what it's going to do is that it's going to examine that particular fiber run just a little bit further. So now this is going to give me information. It's going to give me if there's any protocol errors, or also just even displaying what the messages are between the OLT and the ONT. That can provide me information to verify if there is an issue or something going on. I can look at those particular messages. Okay. But I'm also going to want to, what the customer is going to be most concerned with, especially if they're paying for gig symmetrical speeds, and that's having, gig upstream, gig downstream. They're going to want to make sure that they're getting the speeds, and you're going to have a way of being able to test that. Once again, that's where you have your PON analyzer or a speed tester, and a lot of PON analyzers can have a speed tester that is built in it to look at those layer 4 throughput speeds. So now I can make sure that it's getting the speeds that it's supposed to. Okay, so I want to walk through step by step of how to actually activate a PON network, verify that the PON is set up properly, or that it's performing the way that it should.
Before you do that, okay if we launch another poll questions?
Perfect.
Here we go. So something we just covered. You guys, if you want to go ahead and select one. So the question is, PON optical power meter can test all operating wavelengths without service disruption. Is that true or false? So if you guys wouldn't mind taking your best guess at that. Got 16% voted and counting. Give it another minute. Okay, we're up to 32%, 37, so still coming in. Give it just a little bit longer. So we're up to 47%. Seems to slow down. So Tony, what do you think? Would you mind answering this question for us?
Okay, go ahead and ask the question again, just to make sure everybody hears it.
Oh, maybe you don't.
I'm not seeing it in my end.
Okay, so a PON optical power meter can test all operating wavelengths without service disruption. True or false?
Is that direct to me? Sorry, because I'm not seeing it.
Oh, okay, so PON optical power meter.
Hey, if you can go ahead and answer that, because I'm not seeing it on this end. Sorry about that.
That's okay. I'm just asking the question to you. A PON optical power meter can test all operating wavelengths without service disruption. So
yes, you can. That's true.
Okay, I'm going to close the poll so you can continue.
All right. Okay, so testing the PON network. Oops, hang on just a second. Okay, so now this is one type of PON analyzer that you're looking at on the screen here. Now, depending on the manufacturer, yours could look or you can see one that looks a little different than this here, but it does the similar types of things. So if you look at this here, remember I was talking about pass-through. And you see where it says 2 ONU and 2 OLT. So if I have this midstream, what I could do is where it says 2 OLT, this is my my OLT feed that's coming, that would typically go to my ONU. I'm going to take that directly into here. And then out of here, I'm now going to take that to the ONU. So now, once I have that all plugged in there, my ONU or that ONT is going to come back online. Once it's back online, then I'm able to make my measurements. So I'm able to look at both my my upstream or what's coming or downstream from my information from my PON IDs and all of that, because that's that information that I was mentioning that is important, because this is going to let me know if I'm actually on the right port or not. If this is the ID that I'm supposed to be getting. So I'm seeing that on my from the ID standpoint. But now I can also look at, okay, what is the ONU? What is that giving me? You know, so what's coming back to me? I'm able to look at that. But now, down in this area here, when I was talking about if there was an overlay of the 1550 for the video overlay, then it would show up in here. But now the thing about this particular device here is because it is a PON meter, it looks at just the individual wavelengths and it blocks everything else out. So it's only looking at the wavelength that it is supposed to see. Okay. It also has, in addition to it, is that, remember I said the importance of being able to verify with the customer that they're getting the proper speeds. This particular device here has a copper Ethernet port on it that gives you speeds up to 10 gig. So this is a 10 gig, a gigabit Ethernet port. So don't get that confused with a 1 gig or a gigabit Ethernet port that can give you speeds close to a gig. With overhead, it's going to be a little under a gig. This will go all the way up to 10. Okay. So the tools that that I'm wanting to use, and this is the channel checker. So remember, I got DWDM wavelengths that is getting sent from the head end out of the into the out into the plant. I need to verify. Okay, am I sending the right wavelength to the individual? To the individual points? That's going to give me those individual channels. Then it goes to out of the split. So from the OLT, it's now going to the split, and this is where I was referring to where I'm going the levels from that OLT. This is now coming right here. And then I could have a line coming directly out of here going to my ONT, so it completes the circuit. So and then if I had that through put set up to where it's passing through, it's going to allow me to be able to see both my my downstream and my upstream for for that particular device there. Once everything is looking good, I verified that my light levels is exactly where I want it and all of that. Then the next thing that I want to do is that with the same device, I want to verify, am I getting the proper speeds? So that's going to take me over to doing a speed test. So on this particular device, what I'm going to do is that I'm going to now bring my my ONT back online. So I'm going to take my active fiber from the ONT. I'm going to make sure that I clean the connector. I'm going to connect it to my ONT or ONU. Once the ONU is back online, then I'm going to run an Ethernet cable directly from that ONU over to my test set. If I am testing speeds that are greater than a gig, or I like to use it as just rule of thumb, but for higher speeds, you need at least a Cat7 cable. So remember I said that this particular Ethernet port is capable of getting speeds up to 10 gig. But the thing is that if you want to get 10 gig, you need to at least be using a Cat7. So once this is all set, once this is set up, and I have my Ethernet cable going over to the ONT. All I want to do is just go ahead and say, okay, let's do a speed test. So in this case, I would go ahead and select the speed test. So this particular device, what it's going to do is it's going to go through and it's going to auto configure based off of what my line rate is coming in. So if it's a gigabit Ethernet port, then it's going to automatically set up for a 1000 base T connection. And then it's going to give me an IP address because I need to have an IP address in order to go online and to do speed testing. In this particular case, I'm actually, this is testing through the Ookla servers. And remember that Ookla is like that speedtest.net. So it's going to go through and it's going to ping multiple Ookla servers that's nearby where I'm at, and it's going to look for the one with the least amount of latency. And this is something that the customers will be able to relate to because of the fact that customers, they do speed testing themselves, and that's what they utilize is going to the Ookla, that speedtest.net, and so on. So it's able to go through and get once it finds the Ookla server that it's going to use, then it goes through and it starts doing the speed testing, and you're able to see your upstream and your downstream what your throughput signals are, what your throughput speeds are. Okay, so it's a pretty simple process, but a very important process to verify that the speeds are where it needs to be. You could also, in some cases, you might not want to just randomly go through and select different Ookla servers. You may have a Ookla server that's on your network that you want to test to. You can go in and configure this to go to that particular Ookla server. So now, what some of the areas that's doing PON testing, and you already have your RF test sets, and now you're wanting to do a just PON testing. Another way of being able to do it is to now just go through. So let's say you have your optical tap. Then you have your bulkhead. So in this particular meter, it's going to actually tell me, okay, what am I actually doing? Am I doing an EPON? So in this case, yes, I'm doing EPON. So I select EPON. So this is, just keep in mind, this is what I would use if you're in your network, if you're doing home certifications. This is the way that you would certify this particular home. So I can go through and select EPON, but then I want to tell it, okay, is it at the tap? Is it right there at the ONU? Is it at the bulkhead? Once I select which one that it is, the next step is going to be, it's going to get the light levels. Once it gets the light levels, now I can go ahead and save those results. After I save those results, now it's going to take me over to my speed testing. So now it's going to go through and do those same series of tests going to the servers or wherever you have your test set for. Once it does that particular speed testing, it displays what your results are. And then I can go through and just do a save and upload that to the server. Okay, so that's kind of the process of what you're going to do when you're testing a PON network from a customer standpoint, and you're wanting to certify that home and then upload results to the server. That's just steps that you follow. Now I have like an example. This was one of the tests that was ran, and this particular customer was having some problems. They were just they were getting some very slow speed. So this customer, this was a commercial customer. Now they were paying for 5 gig symmetrical services. Okay, so 5 gig symmetrical. And they were having troubles with the download speeds. And ultimately, what was happening was that when they were looking at some of their IPTV streams, whether it's doing their looking at Netflix or just streaming their service, that they were just getting that spinning wheel because there was buffering that was going on. So we knew that there was a problem. So the first thing that we wanted to do is that it's like, okay, let's go to the ONT. I'm there at the house. Let's just check it out. Now, when we looked at that ONT, first of all, the Ethernet cable that was going there, it right off the bat, it looked a little bit suspect. It didn't seem like it was in very good shape, but we still wanted to test everything just to make sure that everything was fine. So when you're looking at, here's the way that this particular setup was. You had a 5 gig pipe. From that 5 gig pipe, you were going to a wireless router. So in this case, that this was a 1 gig wireless router, but being fed by a 5 gig pipe. So you got the capabilities of a 5 gig of all of the combined traffic going through. So out of that wireless router, it went into a switch, and that switch had some IP phones connected to it. This is a business. But then also off of that wireless router, you had IPTV, and then there was also some wireless devices that was in there that was connected to the wireless router as well. So the first thing that we did is that, okay, let's check for speed. So when the speeds were getting checked, since they were even having issues on their IP phones and the buffering, like I mentioned. So it was like, okay, let's just pull the feed from the IP phone and let's take that directly to the PON analyzer or the speed tester just to see what it's getting. And when you started looking at the speeds, instead of it getting a gig symmetrical, you was only getting, 90 megabits per second, 80 megabits per second. So needless to say, we definitely had some issues that were going on. So we're going through our troubleshooting because remember, it's the same thing. We're doing that divide and conquer. So we know we got slow speeds. So from that point is that we started looking around a little bit further, and we noticed that the Ethernet cable that was from that ONT that was feeding the that router that was in place, the one that we kind of looked suspect from the beginning, we just went ahead and just changed that out because it was an older Cat6 cable. We changed it out to a Cat7. As soon as we changed it out to a Cat7, originally this was coming up as the link. It was linking up at 100 megabits per second. Now it went all the way to a gig. We did our speed test again, and now we had our symmetrical speeds. So now just this, and this was a basic one, but this just kind of shows you the way that you would use your tools. Is that we know that we had slow speed, so now we're just doing our divide and conquer. So at the end of the day, we noticed that it was a bad cable, but we even found out something a little more prevalent is that even though this particular ONT was provisioned for 5 gig symmetrical, what we found was just by going through our pass-through mode that it was getting 1 gig in the downstream and 5 gig on the upstream. Now, this is something that the customer would have never found on their own because remember, it was a 1 gig router that was getting plugged into this 5 gig pipe. So that's all it's going to be able to get is 1 gig. But when you have a lot of traffic going through that particular pipe, you're going to start noticing it bogged down because of the fact that it's not getting the true 5 gig. When you're getting ready to do the downloads and all that, it's not getting it, or for streaming. So it was also found that that ONT was not provisioned properly. It was only provisioned for 1 gig. Once they changed that provisioning or corrected provisioning, it was back at 5 gig. Now we were able to get the symmetrical speeds from the ONT for the 5 gig. And remember, I was able to test it with the device that I was showing you. In this case, it was an FX120. I was able to test those 5 gig speeds because the Ethernet port allowed me to get up that high, but then I was also able to go all the way to the end point, and I was able to see that I was able to get my 1 gig speeds as well doing the testing. Okay, so any questions?
I have one. I'm going to ask the audience. So last poll questions, folks. So please take a minute to vote on the mostly or the best answer for the question. So which statement is not true? OTDR testing is always intrusive. Let me move my OLTS can be used to verify optical loss. Next, PON analyzers can be used to check for protocol errors. Sorry that got cut off a little bit, but I read it to you. So we got kind of a 50-50 split on the answers. Okay, we got one pull ahead a little bit. Looks like most of the audience has got this right. Let's see. Well, we'll let a few more votes come in. We're up to 44%. So looks like it stopped. So which statement is not true? OTDR testing is always intrusive. It's not always intrusive, as T. Donavan said earlier. You can install a filter if you're in a DWDM network. If you have an open channel, that's actually going to go through. But sometimes it is totally intrusive. So it's not always non-intrusive. It's sometimes very intrusive. So just got to be careful with that. So let me shut this off if I can figure out how to do it. Forgive me, it's not coming to me. Okay, no, don't want to do that. Close. There we go. Now we got it closed. So, folks, let's see. Let me see if there's any questions in the chat. No questions there. So no questions from the audience. I would like to just kind of highlight some of the upcoming training we have coming. So, and I got to move something else to see. So let's see. Coming up on 9/13, we have signal leakage in a mid-split, high-split 5G world. 5G being, the new cell phone technology. So leakage is changing. It's going to change a lot for those involved in high-split networks, but it is going to change some of those involved in mid-split networks. In addition, it's always just a useful tool to find network problems. And for everything you fix, it's immediate financial payback. So it always pays to get on and fix as much as you can. I realize everybody has priorities, but every leak you fix is just a future problem that you've resolved. We have tap equalization coming on 10/11. It's an important subject. I know it's kind of simple, but one thing we all have to keep in mind is those equalizers put in taps for a reason. Some techs might just take them out and say, no, that's better. It's not necessarily better. As Tony could tell you, there's a design, right? So if the design isn't working, we have to kind of figure out why, not like remove equalizers. So a big event on 11/28, November 28th. Hopefully everybody can keep their calendars clear. We have let me see what it's called. Okay, Technology and Training Summit. So we're going to have some really great folks. Tony Donavan is going to be one of them. But we also have Jason Roop from Cable Labs. He's going to be on to talk about, the financial model of network maintenance, and show how it really pays. We're going to have Brady Volpe, who's also a leading industry expert. He's going to talk about AI and AI's impact on network maintenance, how we're going to change that's going to be a game changer as we get AI more involved. And then we're going to have Larry Walcott. He's going to talk about what's changing on PNM. In other words, troubleshooting tools using customers' cable modems, because now we have a very nice OFDM and OFDMA signal. Gives a lot of resolution and can tell us more than what we see today. So that's coming down the pipe, and we're going to get more information. And I know everybody's saying like, oh boy, we're going to find more problems. Yes, we're going to find more problems, but that's what we're here for. We're here to resolve problems. So, the more problems we resolve, the less problems our customers experience. So all good stuff. And then I think last for the year, we're going to go really back to basics. We're going to have TDR basics. So we're going to have Springbok, Paul Shea of Springbok is going to talk about TDRs. So if you have any suggestions or any training you would like to see that may not be on the docket, please email me at wfcash@comcast.net. I'll be sure to start working on it. So with that, we'll adjourn. So thank you everybody for joining, and we hope to see you again soon. And thank you, T. Donavan. We appreciate your presentation.
Absolutely. Thank you. Take care.
You too.